Thank you so much, and good afternoon, and I'm glad that everyone is still awake, at least. I know it's late in the day and we've been here for a long time. I'm really happy to be here, and before I dive right into my talk, talking about 3D printing maps, I thought I was going to give a presentation about making data tactile. It would be better complemented for you to actually experience that yourself. So there are some of my prototype 3D printed maps being passed around, so feel free to touch them, pass them around, take a look at them. Today I have in our blue printed filament maps, those are cities in Massachusetts with the streets representing pedestrian and cyclist crashes in the last decade. I know, kind of morbid. And then whoever has the lucky little lavender map is a little bit more timely. That is the US electoral voting map. So enjoy them as I talk about using 3D printed maps and making data tactile. So talking a little bit about why we 3D print a map. So first, I like to talk about interactivity. If you're like me, one of the reasons that I was drawn to mapping in the first place is because I think that maps offer a really unique way for people to engage with data in a way that's quite different and, in my personal opinion, more personable than more traditional forms of data visualization. And this has led me to be interested in other forms, other ways that we can represent data. And I'm coming from a teaching position currently, and in the same way that I try to teach and think about my content and how students engage with content in different ways, I wanted to bring that also to data presentations and try to do something that wasn't just purely visual. And 3D printing maps can offer a different way for someone to interact with data because it's literally both a visual and a tactile experience. From an accessibility perspective, 3D printing maps has been kind of the start of what I'm hoping will be a much longer journey in creating experiences with maps that might be more accessible to people with low or no vision. What I'm going to be showing you today is really just like the bare bones of how to print data on a map. But I think this opens us up to a lot of possibilities for maps to be accessible in different ways beyond what we can achieve when it comes to accessibility in a digital space. And then lastly, creativity. I mean, I have never done 3D printing before I printed maps, and it's just a lot of fun. And it's fun to have kind of that final product that you can hold and touch. I kind of affectionately refer to them as my map fidget toys. And when you're bringing a map into a three-dimensional space, you're dealing with kind of different decision-making and around design and aesthetics, and I have really enjoyed learning to think through this and thinking about what kind of data might be more appropriate for a 3D versus a 2D space, a tactile versus a purely visual experience. So yeah, it's just fun. So now this is practical cartography today, so let's talk about how do we actually do this. So with all things, we're going to start off talking about our data and data preparation. So to 3D print maps, you are going to want to ensure that the data that you want to represent is joined to the geometry that you plan on actually printing and displaying. You can do this in whatever your preferred GIS software is. I worked in ArcPro. In the example of my cyclist and pedestrian crashes, I wanted to actually highlight the streets in each of the cities, and so I joined all of the point locations of where crashes have occurred over the last decade to those actual street segments before exporting them out as a shapefile. We're going to be returning to Blender for kind of the meat and bones of building our 3D model. I work with the Blender GIS plugin, which is, I think, a really user-friendly entryway for people who are into GIS to also work in Blender, because it allows you to actually import shapefiles. It also works with GeoTIFFs, but I primarily am working with shapefiles. And when you import your shapefile, you are able to extrude your features based off of the underlying data. So in my case, I was extruding it based off of the summarized points of crash locations for each street segment. A thing to note, if you are displaying points or line data, in order to print appropriately, you're going to need to add some kind of base. Otherwise, your printer is going to print on a print bed. If those streets didn't have a base, it would be kind of this messy little spider web. Usually the way I do this is I just add in a boundary shapefile. It's pretty easy, but then you could also do a mesh cube, any kind of flat base that will allow you can print then your extruded features on top of that base. And then we get into what I kind of call creative fiddling. Once you bring in your layer that you want to extrude and your base, you're going to have a model that kind of looks like this map up in the top corner here, which doesn't look particularly 3D. And that's because we have to scale up our z-axis. And this is going to be kind of again, this is going to be a little bit more personal preference, practicing with printing what looks interesting and what you can actually meaningfully feel. If you were talking about accessibility, you actually need to be able to feel the difference in the data representation. And so this is kind of like a trial and error and varies depending on what data you're working with. A thing to note is that the larger the study area that you're working with, the more dramatic that z-axis scaling is going to look. So sometimes I encourage, actually, just for the sake of like your file size, to actually scale down the x and y axes before you start playing with the z-axis. But that's more just for the sake of file size. But also if you are starting to incorporate things like, if you wanted to add a 3D printed legend or labels or other things like that, once you start to bring those into Blender, you then, if you don't scale down your map, you're going to have to scale all of those pieces up just really, really large. And so it can just make it a little bit easier to make the original model just a little bit smaller. And then once you're happy with your model in Blender, you'll export it as an STL file. And this is where we get to the fun little aspect of actually 3D printing. So the steps here are going to vary a little bit depending on what kind of printer you're working with. So I work with the Prusa style printers, which the slicing software is basically the kind of the directions for how to print your model is done in Prusa Slicer, and you can import your STL model. But regardless of what kind of printer you're working with, there are kind of a couple of things that you'll want to check for. First of all is if you did add in a base, separation from the base. Sometimes in Blender, if you bring in those two layers, they aren't actually touching. And so if you try to print, like Prusa Slicer will throw up a big error saying, ooh, there's some print stability issues here. It'll tell you that there's actually a gap, or that there's a print stability, that there's a gap, there's missing layers, something like that, depending on your software. And that just means that you need to go back into your Blender model and sort of make sure those two things are touching. The other thing is scale in the printing software. So by default, most of the softwares, when you bring in your STL map, they will downsize the map to the largest size that will fit on the printer bed of your printer, which is great if you are just printing out one model. But for example, in my project with Boston, I wanted to print out, the printers I work with are relatively small, so I want to print out each of the separate neighborhoods, which do vary greatly in size. So when I bring those pieces into Prusa Slicer, I think it's a little hard to see here, but easier to see in the slides. But there is a properties in Prusa Slicer where you have what's called the world size, which is basically like, think about it like the bounding cube of like, this is the bounding cube for the whole model. And then the scale of the model itself, which is basically the percentage of its original size once it's brought into Prusa Slicer. So what I recommend is printing out whatever your largest piece is, and then when you bring in your subsequent pieces, you'll adjust that world size and scale settings to match whatever the original piece was. And then you will export, you'll do something called slicing or exporting G-code. Again, it's going to vary depending on your printing software. And then you can do the fun little effort of actually printing. And if you have the patience to watch your 3D print happen, it can be really fun and interesting. In general, it's going to vary depending on the model. All the ones that I've passed around took about 2.5 to 4 hours to print. And that's just using a basic PLA filament. It's a pretty standard printing material. But hence why I said cue Jeopardy thinking music, because it can take a while depending on how big your model is. And that is all I have for today. So I want to thank you for your attention. I hope that for those of you who perhaps have never used a software like Blender before, this gives you like a little entryway into how you might start to use it. This takes very little mastery of Blender. You're really just working with the Blender GIS plugin and then just the transformation of the scale. But then for those of you who are more proficient in Blender, maybe this gives you some ideas of how you might bring some of your 3D models into a physical space. But I hope this gets, in general, creative thinking going, and I would be really, truly delighted to talk about these projects or answer any questions. And I think since I have like a little extra minute, I'll also just say one thing you might be wondering as well, Lester, I don't have a 3D printer, and that's okay, I don't either. I'm privileged to work at an institution where I have access to a 3D printer, but I just want to say that 3D printing has become a lot more widespread, it has become more accessible. Many public libraries nowadays have 3D printers that you can actually access for free or for a very minimal cost. Also, local maker spaces tend to have these, or I'll give this offer to folks who might be in the Boston area. It can be a good chance to collaborate with the university who does have access to those resources and can do printing with you. So thank you so much, and I hope to see and talk with many of you during the rest of the conference. Thank you.
Give it up for Lester.
No questions.
If we have time.
We do have some time for questions if anyone has one or two. One back there. And if you are checking out those tactile maps, could you please just make sure they get back to the front? I think we have 4 of them, correct? Yes. All right, so we should see 4 tactile maps back here on the front table.
Have you had any reaction from members of the low vision and blind community in regard to the tactile maps?
Yeah, so that's something that I'm actually working with. So we have a staff with disabilities group at Boston College, where I'm coming from, and the head of that is actually a blind faculty member. And so this is actually a project that we kind of are like talking with him about. And so some of the things that I didn't show here is like thinking about how do you like 3D print Braille labels, for example, in up to like standard. But so we have a little bit, but not. That is something that's kind of like what I was saying about having this being a longer journey of making it, actually testing this out and getting more feedback.